Hello, and welcome to this lab that we have called DP Fuse. What we are going to show you is how to use Openshift, Red Hat integration, and 3Scale in order to modernize the way that developers create applications for SAP. That is in line with what SAP is endorsing now, which is to keep the core of their SAP applications clean. So asking the developers to stop creating code in ABAP inside of the SAP core. That has been done for ages, from the beginning of SAP by any customer, and they find themselves that whenever they need to upgrade to a new version of SAP, there's so much code to be reviewed and be touched that the upgrade process can last up to 2 years maybe, and not less than 6 months, which is very cumbersome. So the new philosophy of SAP with their new product suite, which is S/4HANA, is to just keep the core clean, not do any change inside SAP, and to develop it outside of it. So what best platform to develop on that Openshift, because it's completely agnostic of the languages and techniques used, so that gives developers really big freedom. And that's what we want to show the SAP community, that normally tends to be quite old-fashioned. We want to show them how they can use Openshift to develop anything, then use Fuse or Red Hat integration in general to connect these applications that they have created with the core of SAP. Also, a very important role here is played by 3Scale, because 3Scale can be used as an inventory, inventory of all the APIs, a repository of APIs, and it can even monetize or track the usage of these APIs, for example, for customers who are in public clouds. If the developers of their users are consuming APIs that they need to pay for, 3Scale is a very good way to keep track of all this expenditure. So this lab is divided in 6 exercises. First of all, we're going to see how we can use 3Scale to consume open APIs from SAP, and how we can track the consumption and everything related to these APIs. In the second exercise, we're going into Red Hat integration, namely into Fuse and the Camel component, which has connectors for SAP, like the J or Java connector. And we're going to expose from SAP some of the endpoints or APIs, so that they will be consumed in the third exercise by a front-end application, very simple front-end application, but we can see how we are extracting data from SAP and sending data or writing data into SAP. In the fourth exercise, what we are going to see is a very interesting use case, that is to create a serverless application that will, when asked or when a user needs to request some information, will spin up a new pod in Openshift that will connect to SAP, extract the data, come back to the user, present the data, and then it will be scaled down so that they are not consuming resources all the time. Again, this is good for customers that are on hyperscalers. Then we have another part where we are going to see how we can leverage CI/CD and GitOps for SAP. So in order for developers, whenever they change something and they are developing using DevOps technologies, how this can be replicated in the applications that will talk to SAP. So all this to show how DevOps and SAP can go together, which is a big step forward. As I said, traditionally, the developers and the SAP users are very old-fashioned, so bringing the DevOps mentality in the companies is a big step. And finally, the last exercise that we're going to see is showing. And finally, the last exercise of the lab is to show how advanced cluster management works, and this is applicable to any cluster and Openshift. So if we have a cluster that's using integration to connect to SAP, we can use it as well, and it's a very interesting feature. So let's get started with the first exercise. As we said, the exercise for using 3Scale. We are going to consume, as we said, 3 APIs from SAP. What we will need here, it's a user, an SAP user, to be able to connect to api.sap.com. Once we have connected here, what we are going to look for is for our example, we're going to use the analytical reporting APIs. So we'll look for analytical. Well, let's write analytical reporting, because otherwise we might not find it easily. This one is the one that we are going to use for in the lab. Analytical reporting view management API. If we go in there, we can see more details about that. For example, we can see the API specification. We can download it. We will see that later on in the exercise, that we can download the whole API and import it into 3Scale. But first of all, just to get familiar, become familiar with it, we're going just to see how the methods are implemented in the API. And then we are going to create some resources in 3Scale to use this API and track the usage. So if we go to API reference, we can see the methods that are here, that are available. There are 4 methods. And for example, if we go to view templates, we can see this is a Swagger interface, as you can see, Swagger type interface. And here we can try it out directly from here. But if we go to, well, the different, we have model view. If we go to overview, okay, let me go back to the API reference, view management, and yes, so we can see here the 4 methods that are exported or exposed with this API. If we go to try out, we can see more details, right? For example, if we choose one of them, the view templates, and we go to code snippet and we choose curl, we can see an example of a curl request for this API, for this method, sorry. If we go to any other, for example, normal view templates, you can see it more clearly because this is the curl call here is shorter, so we can see what type of request it is. We can see here the URL. This is the base URL that will be used for all the calls that we are going to make to this API. This is very important. This is the API key that needs to be appended to all the curl requests. So we will take this API key and we will insert them in 3Scale, so that we don't need to type this API key at all when we are doing the request. This is good as well to hide it in terms of security, so that users can consume the APIs, but they don't need to be to know the API key. Let's go now to our Openshift cluster. You will have received the credentials for it with your email when you order the lab. So we'll log on that. We need to go to the 3Scale namespace, because that's where all the roots and everything for this for using 3Scale is. So we go to projects and 3Scale. Then if we go to networking and roots, we can see several roots. So the one that provides the, or has the URL to the 3Scale deployed application is this one. If we click on here, well, actually, normally you would see, because I'm already signed in, but you will see this login screen. Okay, so you need to enter your username and password. So the username will be logging with is admin, and the password, to find it, if you go always in the project or namespace 3Scale, and we go to workloads and secrets, we'll be able to find here the password. So the password is in the secret system seed. Okay, if you go here, reveal values, you'll be able to see it here under admin password. So you take it from there, you just put it here, and you will be able to log into your 3Scale. Okay, so what do we need to do in order to use the APIs from SAP and track them with 3Scale or add them to 3Scale? So the first thing that we are going to do is to create a product, and the product will have a backend. Then we need to connect both product and backend, create policies, so create a policy as to how to track the APIs and what we need to do each time the API is called. And then when we have connected the product and the backend, we will create actions for this API and an account, and then we'll be able to see every time that we make a call to this API, we'll be able to see the metrics and we'll be able to see a lot of data around that. So we're going to start by creating the product. So from the dashboard, we make sure that we're on the products tab. We click on new product and we're going to call it, for example, SAP Analytics. The system name, we can call it as well SAP Analytics, for example, and any description. Let's be original and say SAP Analytics. We create a product, right? So we can see now that it's created, and as we said, now we need to create a backend and link both product and backend. So we go back to the dashboard, we change the tab, and we say new backend. Okay, we're gonna call it SAP Analytical. Alright. System name, yeah, SAP Analytical as well. And analytical. SAP, for example. Here is where we are going to use the base URL that we have seen here in the Business Hub. We were looking at the code snippet. Right. We have seen the base URL that we need to include in all the calls to the API. Let's go back to it and take the URL. So the URL is this one, up to sandbox, because after that you can see there is a method already, so the base URL will be up to sandbox. So let's add it here. Okay, this way we have created the backend, and now what we are going to do is associate the product to the backend. So now we go back to the dashboard. Here, if we take the product, which is the SAP Analytics API, okay, we go to integrate this product, and we can see here that we need to add a backend. That's what we are trying to do, right? So the backend would be the SAP Analytical that we have created, and the path we're going to use reporting for this case. For example, we call it reporting. So that's the way we are going to associate the backend and the product, right? And now we can see here the private base URL that we have created. So we won't be showing this in the requests. So the public path will be what is hiding the real URL will be reporting. So that adds a security layer to all our requests to the API. And now what we are going to define is the policy. As we just saw, it was asking us when we try to integrate the backend and the front end and the product. It said that first we needed to create this integration and then create a policy, and then we need to publish this policy. So we're gonna go here to policies, right? And we're gonna click on add policy, and the one that we're going to use here, because what we want to do is to modify and add the API key in our headers when we do a request. So we'll go to header modification, right? We click on here, we can see the options. So in our case, we want to modify and add something more to the request. So if we click on the options, the operation to be applied, we are going to choose create the header when not set and replace its value when set. Header to be modified is API key, because that's what we want to use. We want to add in the header of the request. And how to evaluate value as plain text, because we're going to insert the API key that we saw in the API hub from SAP. Right? This is the value that was here. So if we go here, as you can see, API key, it's going to be always the same for my user in the SAP API hub. Okay. And now we update the policy. Update the policy chain. So it's all recorded and propagated. Actually, I just realized that this is not the correct operation, so we need to change it. It's create the header when not set and add the value when set, because we just need to concatenate the value of the API key. Okay, so we update the policy again, update the policy chain, and now we have the policy that has been created. Okay. Next step is to create an application plan that will allow the developers and the users to consume this API. So we go to applications here, go to application plans. We're going to create a new application plan. So the name, we're gonna call it free SAP API, for example. System name will be SAP or free SAP, we can call it, for example. And that's it. We don't really need, for this trial, we don't really need to fill in anything else. We create the application plan. Right, you can see that is here, right? And here we can see the state that is hidden. We need to publish it. Right, now it has been published, so it can be used by any developer. The next step would be to create an account. So this account will provide the information, top level information, to the users of the API. So we go back to the dashboard, and here we can see that there is we can see the current accounts. This is a sample account. We're going to create a new one. Username, for example, here will be account admin. Email, we can use our own email. I will use mine. And right, we can give any password. An organization group name, we are going to call it, for example, my org. Okay, now the account has been created. Now we will need to create an application now that we have the account that will provide the key to be able to consume the API and authenticate. Okay, so we'll go back to applications. This is what we have at the moment, right? If we go back to accounts and we go inside our account, we can see applications here. The application, no, it's not here. So let me go back to accounts, go to my org, right? And we can see there's one application here. Okay, it's here where we are going to create the new application. So the plan would be SAP, the free SAP API. Service plan default, and we can give any name, test of SAP APIs, just for test, or whatever we want to add here, and we create the application. Now we can see here the user key, and that's what we're going to need for the authentication. The last thing to do before we can actually try our APIs from 3Scale is to promote the API cast that we have created, promote it to stage. So if we go back to the dashboard and we go to the SAP Analytics API that we have created, integrate this product, we can see here the option to promote to stage an API cast. So that's what we need to do. Right, and we can do it to production as well. So in order to test the APIs, we are going to use Postman, for example. So first we will try using the URLs that we could see here and SAP API Hub. So using those servers, so just to compare the the response, and then we will use the APIs that we have. What we have exposed, or we have translated this into on 3Scale. So let's first make this do this test. To test this, what we have created, we will go to Postman, for example, and we're going to do a request with what we have. So we have this staging API cast. That's what the developers and users will see. They won't see the backend, the actual backend of SAP with the actual URL, and they won't see the API key. So that's something that doesn't need to be passed on to the developers, which is a good thing. Each developer, when they create this API cast, will have their own user key, and that's the only thing that they will use. Okay, so in order to do this, we will take first the URL for the request. We create a new request, HTTP request. Okay, as we saw before, the public path is reporting, so we need to add this to the URL. So reporting, and now we need to add the method that we want to use. So for example, view templates. Okay, and we'll concatenate the user key. So each developer will have their user key. Each user will have their user key. Now, if we send the request, we can already see here all the result of it. If we repeat the same request a few times, we will see how it's reflected in 3Scale, and we will see how the statistics are capturing this. Go here and we go to analytics, for example, we go to traffic, and we will see actually that today we have quite a few hits because this has been used. So this is how we can track the usage of searching API, and as you saw when we were defining the plan, we can add a cost to that plan so that it can be reflected here. And as we said at the beginning, if we need to track down the consumption, we can configure alerts when an API is being used too much and limit its usage, which is very interesting. So this is the first exercise of the lab. Now for the second exercise, as we said, what we are going to see is the integration of SAP using Fuse, namely the camel component. So what we have an SAP backend, so it's an S4HANA, and what we have done there is to expose some BAPIs, so business APIs, and using Fuse we have created endpoints, and basically those endpoints will be APIs in the form of a URL, and we're going to use Swagger to call this the methods of these APIs. So let's first go to the right project, okay, in Openshift. So it is a project side by side, And what we're going to look here for is the route to connect to the Swagger API. So we're going to networking. In this project, or this namespace, we have the backend that we have just mentioned, so the connection to the S4HANA, and the front end, which we will see in the next exercise, and it's that front end application connecting to SAP using the same, but we are going to show you how to use Swagger, for example, for this. So this is the route. So if we click on it, we will get an error because we need to add some part to the URL that's in the documentation of the lab, and I'm just copying it from there, add it here. Sorry, not this, but just this, right? Okay, and there we go. So here we can see all the methods that have been exported for this business API from SAP. So it uses a flight model, so it's an example model that comes with an installation of a SAP NetWeaver and SAP S4HANA, and it allows the users to ask about customers, about flights, about carriers. So we can see here the method. So it's one post method that is the same that we will use in the next exercise when we are going to create a customer, so we will use it in the next exercise. We have another method to ask for a customer, use a customer name. Another method that lists of all the carriers in the example. Another one that gets all flights for the carrier American Airlines I have chosen, for example. And then we have the same, but using Olingo 2, because it's another protocol that can be used to interact with SAP using Fuse. And this one, for example, given a carrier, it shows the details of the carrier. We can use this one, for example, for a ANA, for example, for American Airlines. We execute it. We will see all the data for American Airlines. You can see here. If we use, for example, this one, it will, as I said, it will show all the flights scheduled with American Airlines. Let's try it. And here we can see the different flights. Okay, so it's very easy to use. On this part of the workshop, you don't really have to do anything, just to get you acquainted with Swagger and see what you can do and how this is going back to SAP and bringing up the data. So this is basically the second exercise. Let's move on to the second one. In the third exercise, we're going to see how Fuse also can connect to a front end. So we have seen how we can query the backend and how the APIs or the PAPIs from SAP were exposed. We're going to do the same thing, but consuming this APIs or PAPIs from an application, a front end that we have developed, and it's developed when you order the cluster. So again, we're going to be looking into the side-by-side project or namespace. If we now go to workloads, well, if we go actually to networking and routes again, we're going to be looking at the front end. So we have the URL here, and this is our front end. Okay, so we're going to create a customer. What we saw when we use the Swagger APIs, we are going to create a customer here, and we choose a customer type, for example, private, customer name, myself, form, Mr. Street, any street, postcode, whatever we want to put in here, city, we can say London, country, Great Britain, phone, any phone number that we can think of, email, myself.org. Discount, we can say that this customer, I am the customer, is getting a 25% discount, not bad. Language, we'll choose English. Click on submit. So this is the JSON of what's being inserted in the SAP backbone. And now we go to home and we want to ask about this customer that has been newly added. can look for myself. We submit the query. Here it is. Any street, so the same records that we created are here. We can also check, for example, do a wildcard search. We will find the same thing, right? So this is pretty simple. We were doing the same with Swagger. Now we have joined it with an application to show that any application that we develop on Openshift can connect using views to the backend of SAP, write data there, and consume data from there. So this was the third exercise. For the fourth exercise of this lab, we are going to use the SAP example that comes built in with SAP installations of the sales orders. So this is going to show how we can use serverless applications, as we said at the beginning. So the concept behind this lab is that we have the SAP backend, okay, and we are going to use CamelK. So CamelK is another component of Red Hat integration that permits to use the serverless technology. So as in the same way that we have used Fuse and its Camel component for exercise 2 and 3, we are going to use now the CamelK that has this serverless flavor. So instead of what we had before, that we had a backend service and a front-end service running constantly, now we will have, yes, the backend service will be there, but there will be the CamelK that will spin up or scale up pods as needed. If we take a look a bit at the architecture of this, we're going to use Slack for this example. So the customer will send a sales order, a number on Slack, just to see the details associated to that sales order. So for this, what we are going to have, as we can see on the left hand side, this is the SAP backend that we have been using. For CamelK, we are using OData 4. Okay, so that's a protocol that CamelK uses, and is one of the protocols that SAP can utilize to export or expose the puppies. So what we have is the CamelK component here that will scale up and down the pods as needed. We have created channels, so 2 channels, one to receive the request from the user and one to send back the responses to the user. And we have a Camelot. So the Camelot is a component that works as a webhook, and it's listening for the requests that come from the Slack channel that we have defined, right? So there's a Slack channel dedicated to this request for sales orders, and the Camelot will be listening for those requests. Okay, so let's go back to our OpenShift cluster. Now we are going to use the project serverless, SAP serverless, and if we change to developer view, we will see this applications deployed here. So as we were saying, this is a Camelot that is listening on the Slack channel. So it's the connection, the webhook to Slack. CamelK has integration to many applications, so you can use it, for example, as well with Telegram and with many others, or you can create your own Camelot if there's not yet a standard webhook for an application, for a chat application or whatever. You can create it, which is really flexible, gives a lot of flexibility. As we can see, it's listening or is connected to the order check channel. So the moment it receives a request from a user on that Slack channel, it is tied or linked to, it will put this request on the order check channel. This order check channel will be, the request will be sent by this application to the SAP backend, and then once the SAP returns the result, another application will put this this result of the request on this other channel return text. That, as we said, the Camelot source is listening on this channel as well, and will post the results on that channel, on the Slack channel. So here we are going to open our Slack, we need to configure the Slack or create a token to subscribe to this channel. This is the sales order channel where we have deployed our application, or where the cabinet is listening on. So we just need to include one of the a valid sales order number. From this example, if you need to check the sales order number, you can go to SAP and check all the sales orders that are there for the example. So for example, let's copy this one and let's add one here. So the moment I click this, in some time we will see how the pods are scaled up and how the response appears here. So let me do this and let's just watch. Here it takes some time because for the demo we have used a timeout, because well, it is to avoid a big number of requests coming in at the same time, so that it can flood the channel. So we have to wait around 30 seconds. I can't remember how long we put in the timeout. Now we can see that it's starting to scale up. The pod is received the request from the order check channel. Now it's passing it to SAP, and now we can see that we just got the response. Once it is done, the pods will be scaled down again so that no resources are consumed. And as we can see, here are the details of the sales order. So the currency in US dollars, the price, the customer it is associated to, the sales order that we asked for, and the total. As we said, after some time, the pods are scaled down again. So this one has already been scaled down. And finally, the other one has been scaled down as well. So this is what we wanted to show with exercise 5 for exercise 4 for the serverless applications. Now let's move on to exercise 5, which is about, as we said, GitOps and CI/CD. In this exercise, we're going to use Argo CD and Tectron pipelines. So what we're going to show here is that we'll take some code that we have on GitHub, we'll fork that repository, we'll clone it, and once we have installed the Argo CD or deploy the Argo CD operators and Tectron for pipelines, we will connect them to that repository, to our fork of that repository. We'll do some changes in the code, and we will see how this is reflected with the Argo CD and how it creates a CI/CD pipeline, so that we can integrate this application development that is connected to a backend, an SAP backend. We can integrate it in a CI/CD pipeline. So first of all, we'll go again to the side-by-side namespace. Okay, we go back here and let's check the operators that are installed here. So those are the two operators that we will need: the Red Hat Openshift pipelines and Red Hat Openshift GitOps. Okay, so they are there. And then we will need to clone, first fork a repository, the repository we're going to use for this, the sample repository, and we will clone it. So in my case, I have already done it. This is the repository that you need to fork. So I have forked it in my GitHub space. Okay, and I have cloned it as well. So it is here. I'm already in the path where I have all the code, and I'm going to log on to the OpenShift cluster from the terminal to create a new project and then to do the development. So I'll just take the copy login command. here. Okay, so let's first of all create the new project. We are going to call it Openshift GitOps. Okay, and now what we're going to do is, well, actually, first of all, we need to change some of the files here to make them point to our own repository. Okay, so if we go to, we have files for the front end that we have seen in the other examples, and for the backend, so that we can modify code on both. If we go to front end CI/CD, we will need to change first of all the webhook that will connect to Argo CD, and we need to point it to our fork of the repository, because when you first fork the repository, it will have here the name of the original one. So we need to change this one, dev webhook YAML, and then pipeline resources YAML. This is basically the same change in all of the files that we're going to see. Then it's QA webhook YAML, same change. Where is it? Here. All right. Same for dev. So the dev webhook, we need to change it as well. Pipeline resources YAML. Oh, that one, yeah, we have already seen it. And QA webhook. There it is. That's for the front end CI/CD. Same thing for the back end CI/CD. So we go there. We need to change that webhook. Sorry. Right. So is that webhook? Here it is, the change. Pipeline resources also for this one. Here it is. And QA webhook as well. There we go. So everything's changed here. And now we'll do the same with the Argo CD. These changes were for the Tecton pipelines. And now with the Argo CD, we need to change Argo app be QA for the backend QA, pointed to our fork of the repository. Argo be CI/CD, same thing. Argo be dev YAML here. Argo CD FE dev YAML. Same for QA for the front end. And the same thing for the front end and the CI/CD. So once we have changed all this and we are pointing to our repository where we will be making the changes, we are going to create a deployment of the Argo CD. So let's go back to our terminal and we will do OC create. Well, let me just go. So to make sure, okay, Argo CD is here, right? So OC create Argo CD. We use the Argo CD.yaml and we'll call it Argo CD. I missed the -f, sorry, to specify the file. There we go. So we are going to deploy the Argo CD. So create -f with file that we're going to use, argocd.yaml. The namespace where we're going to do the deployment, so it's the namespace that we just created, so Openshift GitOps. So we have deployed the Argo CD now. Okay. We need to create also the cluster role bind. So same thing, we are going to use the cluster role bind YAML for this. It will be created as well. And now that we have deployed the Argo CD and its binding, we are going to deploy or create new applications in the Argo CD. Okay, so all the applications that we have, so the for the backend dev, backend QA, and the front end dev and the front QA, and then the CI/CD applications. So everything that we have, where we have changed to point to our fork of the repository, will be applications that we are developing on Argo CD, so that when we change the code on GitHub, Argo CD will see this, capture this change, and create the CI/CD pipelines. So first of all, Argo CD, we will create the app for Argo app backend dev YAML. Copy this. Now it's BEQ for the BQA for the QA application. Sorry, it's Argo app Argo CD Argo. Yeah. There we go. Same thing for the front end. QA. And then the CI/CD for front end. For the backend. We click on the URL for the Openshift GitOps server. Will take us to the login console of Argo CD. And in previous versions, we needed to get the username, that here was admin, and get the password that can be extracted from the secrets in Openshift, or we can extract it from the command line as well. You can query it. But now, if we are already logged into Openshift, we can click on login via Openshift and just log in with the admin and password of Openshift, of our Openshift cluster. And here we can see all the applications that we have deployed. So the backend for CI/CD, backend development, QA, front-end CI/CD, front-end development, and front-end QA. We can see that all the applications are synced, none are out of sync, so this is looking healthy. And what we will do now is to change the code on some of these applications and see how the CI/CD pipeline is built. Before, if we want to check some details of any of the applications, we can click on them. So it has kicked me out, so let's go back to it. Okay, this is the app that where we had looked in, and it's showing all the resources that it has, and all the rules, pipelines, etc. So if we want to see all the details of the application, they can be seen from here, from the Argo CD. Okay. So now let's do some changes in the code. Before that, let's look at the projects for the applications. So we go to projects in the Openshift console. And we choose, for example, this one, front-end CI/CD. We go to pipelines. You can see that there are two pipelines, so one for development and one for QA, because we have created the applications on Argus AD. We have created detection pipelines, but they have been not run at all because we haven't changed anything. We will see that once we change the code in our GitHub repository, in our fork, we will see here how the pipelines are going to run and the statistics to be updated. So apart from the CI repository that we have forked and cloned, we also need, for this lab, for this example, which is in the documentation, we need to fork these two repositories, and that's where we'll actually do the changes, the modifications, one from the front end, another one for the back end. Okay, we go to the front end. We need to configure a webhook for both of them. First of all, let's look that we have two branches. Well, we have, apart from the master, we have a dev branch and a QA branch. So we need to create webhooks for both branches in both repositories, so that when we make changes, they'll be connected to our Argus CD and our detection pipelines. So if we go to dev, go to settings, and we go to webhooks. I have already some webhooks created from another test, so we will need to modify the actual URL. Here we go into edit. We just need to put the right URL here. So if we go to our Openshift console and we go to the app front end, because we are editing the front end CI/CD, we go to the webhook. So we can see here, this is the right URL to put there. Okay, application JSON, enable SSL verification, just to push a ban, active update webhook. Right. We'll do the same thing for the QA branch. Things. Webhooks. Edit this one. We'll go to the other route, to the QA route, and take this URL. Okay, that should be fine. And now we'll do the same for the backend. Go here. And we need to do the same settings. Webhooks, and we'll modify the dev and QA webhooks. Here we need to change the project and go to the front-end CI/CD. Change the URL. Update it. That was for dev, right? And now for the QA. We'll do exactly the same. Okay, settings, webhooks, QA. Okay. Okay, now our webhooks are updated. So let's simply do a modification in the B, for example, in the backend. We can go to the dev branch, and modify, for example, the readme.md. You can see that there was some tests already here. Well, let's say new test. We just commit directly to the dev branch. Easy. And now we can see that the pipelines are running, so the different stages. I have made a modification also in the QA branch, so we have 2 pipelines running, and in some time we will see the stages and when they're finished. So here we can see in real time what they're doing. You can see the logs normally appear in real time, right? And as I said, in some time we will be able to see the pipelines completed. And now we can see that the QA pipeline has finished. Okay. All the stages are okay. And we can see that the dev pipeline has failed, so we can check here okay, it was because there was another pipeline running as well, so because I did 2 changes, one after the other, so that's why one pipe overrun the other. But normally, if you just do a change and wait till the pipeline has finished, there will be no problems. So this is the exercise for GitOps and CI/CD. And let's move on to the last exercise that we are going to show how to use the advanced cluster management. So in this last exercise for the advanced cluster management, what we are going to do is to create a cluster hub with 2 Openshift clusters. So the one that we are using for all the exercises, and also another cluster that will be the actual advanced cluster management. And we are going to use them to deploy applications on top of them and monitor those applications. And we will create a policy by which the applications will be monitored. Okay, so first of all, we are going to check if the advanced cluster management operator is installed. In our case, it shouldn't be. Let's say. Right. So we don't have it here. We go to Operator Hub, and we're going to look for it and install it. So if we put cluster management or advanced cluster, there we go. This is advanced cluster management for Kubernetes, right? We're going to install. Oh, this is advanced cluster security. Okay, so we're going to install cluster management, just the basic install. For all namespaces, right? This will take some time. As we can see during the installation, it's already telling us that we need to create a multi-cluster hub. That will be the next step once the operator is installed. Once the operator has finished installing, we can see it succeeded. Okay. So we're going to go to the Open Cluster project that we have for the namespace Open Cluster Management. We can see actually the operator is here, right? And if we go to Multi-Cluster Hub, oh yeah, even here in details when we just went to operator, it was telling us to create the Multi-Cluster Hub. So let's just do it from there. Okay. We'll just leave the default multi-cluster hub and we're going to create it. This will take some time. Once the multi-cluster hub has been installed, we can we're going to see here that we have the link to the ACM console. It is here, right? So it's the same login and password as for the normal cluster. See it here. If we go to clusters, we can create a cluster, and that's what we're going to do. So this is OpenStack platform. Okay, so we'll choose that. So once the multi-cluster hub has been installed completely, what we're going to do is to go to the advanced cluster management console that we can see here now. So we open the link. The credentials are the same as for the Openshift cluster. Okay, welcome there. And this is a console. If we go to clusters, because we're going to create a cluster now. Actually, we're going to import a cluster. Okay, we will call it local cluster, and right mode. The import mode will be enter your server URL and API token for the existing cluster. So we are going to need those details from the token details from the Openshift cluster. So you know, when you do a copy login command, you go to here, we're going to need this URL, okay, and this token. So let's just copy them with the port. That's the URL. Let's take the API token. Okay, right. We are going to add a couple of labels here. That's to monitor the applications that we will create. So app front end and equals true, because we will create an app called application front end, and another one for the backend, app BA equals true. So meaning that we want to monitor these two applications. Okay, and now we import the cluster. Okay, I've created a local cluster, so I need to change the name for that because that already exists. Sorry. So I will call it new cluster. Okay. There we go. And the import is going to take a bit long. We can see the status here in add-ons. Once the new cluster has been installed, we can see it here as well in clusters. And we are going to add the same labels, so the same tags that we've added to the new cluster, we're going to add them to the local cluster, right? Okay, so we edit the labels and we add appd equals true and appfe equals true. Okay, now we will go back to our original cluster, and we choose the Open Cluster Management project. We choose the developer view. We can see here all the applications that have been deployed in the cluster. Yeah, so there are loads. So or that time while the new cluster was being created, it was installing all these applications. And if we go back to the administrator view and we check the pods, we'll see lots of pods, all those that we have seen in the topology. So workloads, pods, and they're all running, so that's good. Everything's been created as according to the plan. And now we are going to create the two applications, one for the back end and one for the front end. As we said, we go here to applications. We say create application, subscription, for example. And we are going to call it SAP backend. The first one, for example, the namespace we will call it APPEACM. Okay, repository. Sorry, it's going to be of type Git because we are going to link it to the Git repositories. So now we need to take the URL for the Git repository. Okay. Right. And now we are going to add the tags. So the same tags that we have added before for the backend. Sorry, that's later on in labels. What we need to add is the branch, which is ACM. Yeah, and the path, which is the backend. And further down, we actually have the labels. For this one is the APPBE. The value is true. Okay, so we just save it, and we're going to create the other application as well. Okay. We're going to create another one for the front end. We will call it SAP FE. Namespace will be APP FE ACM. Again, the same repository. Right. Branch will still be ACM. And the path will be APP FE for the front end. And the label to add is APP FE with the value true as well. That should be it for the applications. So now we can see that the applications have been created. Okay. And the last step now is to create the policy to monitor the cluster. So we go to governance. And we're going to create a policy. So the policy for this example is in the GitHub repository, one of the GitHub repositories that you've cloned and forked. So the side-by-side CI, sorry. So it's in the branch ACM, and it is here, policy YAML. We just need to copy this and paste it in our console. We need to delete all this. We will leave it like that, policy dash grc. We create everything, and we can see that everything is being filled in here. Okay, so we just create it. It's been created. Now we can see it in the list on the list of policies. This is what we are defining in the policy. So there must be one pod, only one CPU, 1 gig of memory, 2 gigs of ephemeral storage, right, and for the limits of the CPU one. So we see request CPU, and we have to put the limit. So minimum 1, limit maximum 1, minimum memory 1 gig, maximum 4 gigs, and minimum storage 2 gigs, maximum storage 10 gigs. That's what we have defined in this policy. So at the moment we can see that the policy is not being compliant, so it says cluster violations. So this is the policy, right? And if we go there to see the details, why it's not being compliant. Okay, view details. If we scroll down, we will see not compliant and resource not found but should exist. This is because we haven't we haven't assigned quotas. No, we haven't defined them. So that's why it cannot know what the real usage is, and the policy cannot be applied. So we need to define and assign those quotas. The fastest way to create these quotas is to enforce this policy. So we go back to the policy. Once we have done this, the quotas will be assigned automatically. We just need to do this, enforce. We confirm. And that will be it. So now, after the quotas have been created, we can see that the policy is being is being followed, and there are no cluster violations, so that's okay. And this will be the end of the lab. Thanks for joining, and thanks for getting here. I hope you have learned a lot.